Okay, lesson 3. So our function, and you'll notice I've started putting our new functions in there. So 7, you can see it, 7e to the x plus 5x cubed minus 3. And now when you differentiate that, so e to the x differentiates to give me e to the x, and times by 7, so it's get 7e to the x. 5x cubed, well, times by the power to get 15, then take away 1 from the power, so 15x squared. And then minus 3 just disappears. My differentiate goes to 0. And then integrate it. So I have to think what differentiates to give me e to the x. Well, e to the x. So therefore, e to the x integrates to give e to the x. So if I integrate e to the x, I just get e to the x. And if I integrate 7e to the x, I just get 7e to the x. Integrate 5x cubed, so add 1 to the power. And then divide by that power. So 5 over 4. Integrate minus 3 gives me minus 3x, and I need a plus c. When I integrate a constant of integration, don't know what it is, haven't got the information to work it out. So that's that. Okay, the second one, we have f of x is cos x plus 10, and g of x is cos 2x plus 10. Okay, so hopefully you can spot that g of x is just f of 2x. So therefore, the x is times by 2, so it's a stretch in the x direction. And since it's inside the brackets, we do the opposite, so the scale factor is a half, not 2. Okay, third one, ln 3x minus 4 equals 7. So get rid of the ln by doing an e, so 3x minus 4 e to the 7. Get rid of the minus 4, so plus 4, so 3x is e7 plus 4. And get rid of the 3 by dividing by 3, so e7 plus 4 divided by 3. Okay, fourth one. We've got an arithmetic sequence that starts like this, and we're told it's arithmetic, so that means the difference is equal. So to get this difference, I do 3k minus 1 this term, take away this term. And to get this difference, I do 2k plus 4 minus 3k minus 1, this one here. Simplify that, so I get 2k minus 1. Simplify this, so I get minus k, 4 minus minus 1, so it's 5. So I get 3k equals 6, so k is 2. So my sequence now becomes 2, 5, and 8. So it's definitely arithmetic. So A is 2, D is 3, because it's going up in 3s. And if we want the sum of the first 50 terms, so let's make a bit more room, so I want S50. So the formula is n over 2, so 50 over 2, times 2a, so 2 times 2, plus n minus 1, so 50 minus 1, times d, times 3. Stick all that in your calculator. And you get 3775. Okay, and the last one is in mechanics, so hopefully you've drawn a picture. That's the best way of doing mechanics. We have particle, mass 5 kilograms. It's on a rough plane, so that means it's friction, so it's going to be a mu. So there's the weight going down, so 5g, normal reaction going up, so r. We know there's no other forces apart from a pushing force. We know the coefficient of friction is 0.2. So, and we know there's a pushing force of 30. So it's going to go this way. Yeah, there's going to be friction pulling it back. So we need to work out what is friction. So using the formula, friction is less than or equal to mu times r. Well, to get r, if I just resolve up and down look, r has to equal 5g because there's no acceleration in this direction. So up has to equal down. So friction is less than or equal to 0.2 times 5g. So that just gives me 1g, which is 9.8. So I've got 30 pulling it this way. This can be anything up to 9.8. Now, since 30 is bigger than 9.8, friction has to be 9.8, has to be the g. So I've got my equation of motion. I've got 30 pulling forward, take away g pulling it back, and that equals my mass, so 5 times the acceleration. So just divide this out by 5 to get the acceleration. So 30, take away 9.8, divided by 5. So we get A equals 4.04. But I've used 9.8, so A has to equal 4.0 meters per second squared.